Hi, I'm Melinda Webster from UAF's Geophysical Institute. Today, I'd like to share a story with you about the journey in science from the largest Arctic expedition in history. The expedition took place in the central Arctic, and there it focused on the sea ice system. Sea ice is incredibly important. It helps drive ocean and atmospheric circulation, regulates our climate, and it serves as a platform for people and animals to travel, hunt, and live. But the Arctic is undergoing drastic change. It's warming faster than any other region on our planet. As a consequence, the ice is becoming thinner, younger, and less extensive. So, why does this matter? Well, these changes have cascading effects on the atmosphere, ocean, and ecosystem, and ultimately our weather and climate. It's these changes in the Arctic system that motivated a year-long drift expedition. This expedition was called Mosaic. It was a field experiment in which a ship was frozen into the ice pack to drift across the Arctic basin to study how the Arctic system functions over an entire year. It was huge. It involved more than 500 scientists and 37 nations, all focusing on better understanding how the Arctic is being affected by and affecting our changing climate. My participation in the expedition began in the spring, just as the sunshine was returning to high latitudes. With increasing sunshine comes a physical transformation of the surface. It goes from a frozen snow covered ice cape to one free of snow and covered in melt ponds. My role in the expedition was to help document the seasonal evolution of surface and optical properties to relate to satellite measurements and climate models. I, together with my colleagues, are using this comprehensive suite of field observations to improve satellite retrievals and to develop new approaches for extracting information from satellite data, such as ISAT-2. We're also using mosaic observations to evaluate and improve climate models. In this example in the upper left, you can see a huge change in snow, sea ice thickness, and melt ponds from early spring and midsummer. Can models reproduce this change? So we compared the seasonal coverage of melt ponds in climate models and observations in the lower right. What we found was a pretty big difference. The models overestimate the area covered by melt ponds, which has important implications for surface albedo. This points to possible deficiencies in model physics, which we'll tackle next to improve our ability to accurately simulate sea ice and Earth's climate. To bring it back to the big picture, with the help of Mosaic, we're improving our understanding of the impacts of climate change on the different components of the Arctic system. By filling in these knowledge gaps and by bringing observations and climate models together, we're improving our ability to predict our future climate and weather. Thanks for listening in. It's been a privilege to share this presentation with you.